Hi everyone, welcome to a new session of your class. Now in this class we are going to take as the second part of our chapter number 7, cubes and cube root. In the last class we have seen how to find cube of a number, then what we learned what is a perfect cube, then how to find or how to check whether a given number is a perfect cube or not. In this class we will learn how to find cube of a given number, or if a perfect cube is given to us we can find whose cube is that one. In the last chapter, squares and square roots, we just saw how to find square root of a number. Similarly, we will learn how to find the cube root of given perfect cubes. Let's see. First of all, if we are given, we just saw how to find volume of a cube last class. I'm going to use the same concept. Suppose given that volume of a cube is equal to 125 centimeter cube. It is given like this. Volume is equal to 125. We know how to find volume of any cube. Volume of any cube is 3 times or thrice the length of its side. That is, if the length of a side is A, then volume is equal to A into A into A. So that means a particular number, when multiplied it thrice, you will get 125. Who will be that number? That is some number when multiplied A times A, that will give as 125. Since we have learned in our first class the cubes of numbers up to 10, you can easily imagine whose cube is 125. Whose cube is that? It is clearly 5 times 5 times 5. That is 125. Or you will write 5 cube as 125. So, if the volume of a cube is 125, its side is equal to 5 centimeter. That is the operation that unknowingly we have done. We have just found the cube root of 125. In the last chapter, we saw square root of a number. For example, square root of 64. How do you find? It was 8. Similarly, this also has a particular method. For example, we just saw that 5 cube is equal to 125. Now take the inverse operation, that is root of 125. But we use a different notation. We will put a 3 here and we will read this as cube root. So how will you read this one? Cube root of 125, and we can write it as 5. I hope you understood the concept. Let's make some more clarity. We have seen that 10 cube is equal to 1000. Then what can you write as the reverse operation? The cube root of 1000 is equal to 10. Then what will be cube root of 3? Can you say? Yes. For knowing this one, we just need to check whose cube is 8. Whose cube is 8? It's 2 cube. So we can write cube root of 8 is equal to 2. Then cube root of 27. Who is cube root of 27? It is 3. Then cube root of 260. Who is it? So similarly, we can find cube root of any number. Who is cube root of 216? 6. So that's the conclusion. We can find the cube of any perfect number. Now you will be thinking how to find cube root of numbers bigger, or how to find cube roots of bigger number. Let's see that also. Now let's try to learn how to find cube root of any perfect cube. For this method, we will take the help of the method that we have learned in our last class, that is prime factorization method. During that particular topic, we learned that every cube number or every perfect cube can be grouped into a group of 3. So, using the very same concept, I am going to find the cube root of any given perfect cube. For example, take the number 3375. I am going to find the cube root of 3375. Let's see. the method is prime factorization method. So you just need to prime factorize 3375. Let's see what are we going to get. How many 3's in 3? 1. Then 1. How many 3's in 75? 25 times. So again we can use 3. How will we check whether it is divisible by 3? Just add all the digits. 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 5 is 5. Sorry, 4 plus 5 is 9. 9 is divisible by 3. So we can go for number 3. Then what will we get? How many 3's in 11? 3 times. Then how many 3's in 21? 7 times. 15? 5 times. Now 3 plus 7 is 10. I hope you know this method to check whether a number is divisible by 3. Just take the sum of the digits of the number. If it is divisible by 3, then the whole number will be divisible by 3. See, 3 plus 7 is 10. 10 plus 5 is 15. So it's divisible by 3. I am going to use 3. How many 3's in 3? 1 time. How many 3's in 75? You know it's 125. Now to check whether it is divisible by 3, take the sum. 1 plus 2 is 3. 3 plus 5 is 8, which is not divisible by 3. So we will go for the next prime number, that is 5. Of course 4 is not divisible. Then using 5 we can cancel it 5 times, 25 times. Again a 5 can be used. So this will be here 5 and 1. So we can write 3375 as 3 into 3 into 3 into 5 into 5 into 5. Now we can make this into group of 3 times a number, 3 times another number. Now the shortcut is that take one each number from one group. That is, take a number 3 from here and a number 5 from here and multiply both of them. Who is the product of this one? It is 15. This is our required answer. Or you can write cubic or cube root of 3375 is equal to 15. This is the method to find cube root using prime factorization. I know it's very simple. Just go for more further examples, then it will be more and more clear for you. Now let's do one last problem based on the very same topic. We are going to find the prime or the cube root of the number 10,648 using prime factorization method. Now let's start. First we will prime factorize this number 10648. We can initially use the number 2. So how many times? 5 times. 64, there are 32 times. Then 4 times in 8. Again using 2, we will get it as 53. We have 26 times. Then in 12 we have 6 times. We have 2 in 4. Then again by 2 we can see 13, and in 62 there is 31. Now we can prime factorize this using the number 11. How I got is that I took the sum of the two alternate number, it is 4. Then the next two alternate number is 4. 4 minus, if you find the difference, it is 0. If the alternate numbers sum and the difference is 0, we can conclude that it is divisible by 11. I am going to use that. So 11, this was already learned in our class 6. Please go through if you have any doubt. Now using 11 we can cancel this. So how many times? 1 time, remainder is 2. This is 23. How many times? 2 times, remainder is 1. This will become 11, that is 121. Again using 11 I will get it as 11. We can further cancel, and the prime factorization of 10648 can be written as 2 into 2 into 2 times 11 times 11 times 11. Now is this a group of 3? Yes, here it is. Take one each member and multiply. So it will be 2 into 11 is 22. So what can you write? Therefore, cube root of 10648 is equal to 22. I hope this method is very clear to you. That is the conclusion of this chapter. We have learned almost everything from this chapter. Just go through the video from the first to understand more and more. Thank you. This is actually an additional video that is going to be presented in front of you. Even I am most privileged to say the names of one of the most important and decorated world mathematician, our favorite or the Indian mathematician genius Srinivas Ramanujan, also another mathematician Hardy. They two together have contributed so much to the world of mathematics. One of such biggest contribution is the number Hardy-Ramanujan number. This is occurring after an incident that happened in the real life. The incident is once when Ramanujan was lying in a bed, that is in a hospital, Hardy came to visit him, and Hardy said, "Oh, Mr. Ramanujan, I'm having a bad day today because the number of the taxi that I came was just replicating the same to me, because the number of the taxi was 1729. I have not seen such an unlucky number in my whole life." And then Ramanujan just sat and just thought, okay, what's number 1729? And he said, "Hey, Mr. Hardy, actually the number 1729 is not at all an unlucky number. It's one of the luckiest number." And Hardy was embarrassed. How can you say that? Then Ramanujan told, "See, the number 1729 is the smallest number that can be expressed as a sum of two cubes in two different ways." And he clarified the number, okay, what was that number? 1729. This 1729 can be written as the sum of cubes of two numbers, not one but twice, two different cubes. For example, I will demonstrate that using an example. Now, to our class, whatever we have learned was the cubes, and the chapter was cube and cube roots. In that, we just saw how to find cube. So we are just using that concept here. Take the number 1729. Ramanujan, in his mind, he calculated this as the cube of two different numbers. The first number is 10 cube plus 7 cube. You know what is 10 cube? What is 10 cube? 10 cube is 1000. And what is 7 cube? It is 729. So this is one way. Can you find the other way? Just try, or if not able, just listen here. The number is 12 cube plus 1 cube. Now 12 cube is 1728 plus what is 1 cube? It is 1. So both of the numbers will be having the sum as 1729. So Ramanujan said this is the smallest number of such kind. There are infinitely many, there could be infinitely many numbers of this format. One of such number is 4000. The next set of number is 4104. This can be expressed as either as 2 cube plus 16 cube or 4 cube plus 15 cube. So this also can be expressed as sum of cubes of two different numbers twice. That is the concept. So such type of numbers are called as Hardy-Ramanujan, or specifically this number is called as Hardy-Ramanujan number. This is just an additional information, nothing much important, but as a mathematics student you should know all these kind of things. That is it. So that is the conclusion of our chapter. If there is any doubt, please inform me, and there are a lot of exercise questions given in the textbook. Please try to solve them and you will be good. Thank you.